This ATLAS telescope image shows Comet 3I Atlas at the moment of its discovery on July 1st, 2025. The faint moving point, highlighted in the zoomed-in frame, was first recognized by the NASA-funded ATLAS survey in Chile and later confirmed to be an interstellar object entering our solar system. The dense star field around it reflects the region the telescope was monitoring for near-Earth hazards. Although barely brighter than the background stars, its unusual motion immediately drew scientific attention. Hubble captured this view of interstellar Comet 3I Atlas on July 21, 2025, when it was about 277 million miles from Earth. The image reveals a bright icy nucleus surrounded by a teardrop-shaped dust coma formed as sunlight warms the comet's surface. Because 3I Atlas arrived from beyond the solar system, this material represents unaltered debris from another star's planetary environment. The streaked background stars highlight Hubble's tracking of the comet as it moved rapidly across space. This James Webb Space Telescope infrared map shows interstellar Comet 3I Atlas as observed on August 6, 2025, using the telescope's near-infrared spectrograph. The image reveals how reflected sunlight and warm dust create an asymmetric glow around the comet, with the brightest region marking the compact icy nucleus. James Webb Space Telescope spectral data allows scientists to study the comet's composition and dust environment in exceptional detail. By tracking 3I Atlas in infrared light, astronomers can probe material that formed around another star long before entering our solar system. These three James Webb Space Telescope maps show interstellar Comet 3I Atlas as observed on August 6, 2025, using the telescope's near-infrared spectrograph. The left panel displays the comet's reflected light image, revealing the bright icy nucleus and its asymmetric dust glow. The middle and right panels isolate emissions from CO2 and H2O, allowing scientists to directly measure which gases are escaping from the comet as it warms. Together, these infrared maps give astronomers a rare chemical fingerprint of material that formed around another star before entering our solar system. This infrared image from NASA's SPHEREX mission shows interstellar Comet 3I Atlas during observations taken between August 7 and 15, 2025. Seen at a wavelength of 4.3 microns, the comet appears as a faint glow against a dense backdrop of infrared stars. SPHEREX's wide-field spectrophotometry allows scientists to study how the comet reflects and emits light as it travels through the inner solar system. These data help researchers trace the chemical makeup of material that originated around another star. NASA's SPHEREX mission captured this infrared view of interstellar Comet 3I Atlas as a softly glowing source against a noisy cosmic background. The image reveals the comet's warm dust and gas envelope, which appears brightest at the center and gradually fades outward. SPHEREX's spectral observations help scientists study the comet's composition as it travels through the inner solar system. This detection adds another dataset to the growing multi-mission record of 3I Atlas. NASA's Psyche spacecraft recorded this wide-field view of interstellar Comet 3I Atlas during a series of observations on September 8, 9. Against a dense starfield, the comet appears as a subtle, compact glow whose motion is tracked over several hours. A zoomed-in set highlights the faint coma surrounding the nucleus captured through Psyche's multispectral imager. These measurements help refine the comet's trajectory and improve understanding of its evolving dust and gas envelope. A video captures interstellar Comet 3I Atlas as a small bright point drifting through a turbulent solar wind background. Despite heavy image noise, the object's steady presence stands out from the shifting plasma structures. These observations help confirm the comet's position and motion as it crosses the inner solar system. The footage represents one of several spacecraft detections contributing to the mission's wider tracking effort. This image shows interstellar Comet 3I Atlas as a faint, glowing point at the center of the frame. The comet was captured between September 11 and 25, 2025, using the spacecraft's heliocentric imager 1, which observes the inner solar system in visible light. Multiple exposures were stacked and colorized to make the rapidly moving object stand out from background noise. These observations help scientists track 3I Atlas as it speeds through the solar system at nearly 130,000 miles per hour. This diagram shows the relative positions of NASA's Lucy spacecraft, interstellar Comet 3I Atlas, and Earth on September 16, 2025. The white dashed line traces the comet's steep, hyperbolic path as it moves through the inner solar system, passing near the orbit of Mars. Lucy's trajectory in red brings the spacecraft into a favorable viewing geometry as it continues its long mission to study Trojan asteroids. These alignments help NASA assess potential observation opportunities for studying material arriving from another star system. This image from NASA's Lucy spacecraft shows interstellar comet 3 I-Atlas as a faint, bright point with a soft halo of gas and dust. Captured on September 16, 2025, using Lucy's high-resolution L-LORRI camera, the view was created by stacking multiple exposures taken while the comet was approaching Mars. The image reveals both the compact coma and a subtle tail extending to the right, even from a distance of 240 million miles. Observations like these help scientists study how an interstellar comet behaves as it moves deeper into the solar system. This combined image from NASA's Punch mission shows interstellar comet 3 I-Atlas as a bright point with a short faint tail extending to the right. The view was created by stacking observations taken between September 20th and October 3rd, 2025, when the comet was about 235 million miles from Earth. Punch's wide-field cameras capture the subtle flow of dust and gas around the comet, while background stars appear as streaks due to the long exposures. These measurements help scientists track how 3 I-Atlas interacts with the solar wind as it moves through the inner solar system. This ultraviolet image from NASA's MAVEN spacecraft shows hydrogen gas surrounding interstellar comet 3 I-Atlas as it neared Mars on September 28, 2025. MAVEN's imaging ultraviolet spectrograph separates hydrogen from different sources, revealing the comet as the small dim spot on the left, distinct from hydrogen emitted by Mars and from interplanetary space. The compact shape of the comet's hydrogen signal shows that the emission is confined to the comet itself, rather than forming a large extended cloud. These observations help scientists study how volatile materials behave around an interstellar object entering the inner solar system. This animation from NASA's Punch mission shows interstellar comet 3 I-Atlas moving across the sky between September 28th and October 10th, 2025, when it was 235 million miles from Earth. Each frame is a stacked daily image built from multiple observations, revealing the comet as a bright compact point against a noisy background. As the comet travels, background stars appear as streaks of light, and in several frames the bright object passing nearby is Mars. These observations help scientists track the comet's changing brightness and motion as it moves deeper into the solar system. This image from NASA's HiRISE camera aboard the Mars Reconnaissance Orbiter shows interstellar comet 3 I-Atlas as a bright condensed glow. Captured on October 2, 2025, the comet was about 0.2 astronomical units from the spacecraft, roughly 19 million miles, 30 million kilometers. Even from this distance, HiRISE detected the compact coma surrounding the icy nucleus as the comet sped inward through the solar system. These observations provide a rare close-up look at an interstellar visitor from Mars' vantage point. This Mastcam-Z image from NASA's Perseverance rover shows interstellar comet 3 I-Atlas as a faint smudge at the center of the frame, marked by a crosshair. Taken on October 4, 2025, the comet was about 18.6 million miles, 29.9 million kilometers from the rover as it explored the rim of Jezero crater. The streaks across the image are background stars blurred by the long exposure needed to detect the dim comet. From the surface of Mars, Perseverance provides a rare planet-to-comet observation of an interstellar visitor passing through the solar system. This ultraviolet image from NASA's MAVEN spacecraft shows the glowing halo of gas and dust surrounding interstellar comet 3 I-Atlas on October 9, 2025. The brightest central pixel marks the comet itself, while progressively fainter shades reveal hydrogen atoms released as sunlight vaporizes its water ice. MAVEN's ultraviolet spectrograph detects this hydrogen cloud as it expands into space, offering a chemical fingerprint of the comet's activity. These observations give scientists a detailed look at how an interstellar comet reacts to solar radiation inside the inner solar system. This faint image from the ESA-NASA SOHO mission shows interstellar comet 3 I-Atlas as a small brightening near the center of the frame. The view is based on combined observations taken between October 15 and 26, 2025, revealing only a subtle glow from the comet against a noisy background. Although barely detectable, these SOHO measurements help track the comet's motion as it moves closer to the Sun. Such distant detections are valuable for building a continuous timeline of the comet's activity through the inner solar system.